So in this question, we are asked to draw the energy change versus composition variation for both B greater than 0. There are two cases we have to address: B greater than 0 and B less than 0. That's the case number 2. So here, uh, if we get the Flory-Huggins relationship, delta F equals delta U minus T delta S, and here delta U is the change of internal energy and minus T delta S is the entropy contribution, and the question it says this part is 0. So therefore delta F equals delta U, and we know the relationship for the Flory-Huggins interaction parameter, which is chi equals A plus B over T, and delta U equals K T chi phi A times phi B, right? So here K is the Boltzmann constant, T is the temperature, chi is the Flory-Huggins interaction parameter, phi A and phi B are the volume fractions of A and B, right? So if I substitute this chi instead of this chi here, right, I can get KT A plus B over T multiplied by phi A phi B. So then here I will get KT A, and here I will get B, T to T cancels, so therefore KB, which is multiplied by phi A plus phi B, right? So here K term is common, so therefore I can write this is TA plus B times, I will say K times phi A plus phi B. Sorry, this is not phi A times, right? So this is a product, and this is phi A times phi B. Alright, so this is delta F. Now in this question it says that the mode value of A is smaller than B, right? And there should be a correction in the question. So this should be significantly smaller, right? So it's not only smaller, significantly smaller. So let's say like this value is 5 and let's say this number is 10. Alright, so then B greater than 10, 0 mean this is positive 10, B less than mean let's say it is negative 10, right? So let's consider the case number 1, first one, right? So then here delta F equals T times A. T is a temperature. Let's say my temperature is 300 Kelvin and A is small, right? So it is 5, right? Normally these values are A and B values are really small numbers, something like 0.005, right? So this is, let's say, 0.1, something like that, right? So if this is 0.005, right, if I get 5, like it will be difficult to explain this question. So let's say 0.005. So then my answer here 300 times 0.005, and here this is 0.1, and then I have these terms. So Boltzmann constant times phi A phi B, some numbers, right? And here in the first case I will get a positive number, right? So delta F is a positive number because this is a positive and this is positive, so therefore some number I will write n times K phi A phi B. So that means delta F never be negative phi value. So therefore if I start to plot this one now, I can say, okay, if I get this one, so let's say this is my delta F versus 5, right? Let's say this is my 0, 0, right? This is 0 and here this side it's positive and this side it's negative, right? So then if B, in the first case, if B greater than 0, so this value will be positive. It's something like that, right? So this is the 0 mark, right? So this is when B greater than 0. B greater than 0. So then let's evaluate the second case. In that one, B is negative number. Here let's say now this is delta F. So delta F equals 300, this is same as 300 times 0.005 because we are not changing A. But B, now it's a negative number, right? Let's say it is negative 0.1, right? It's 0.1, negative. So then you have this term K, phi A, phi B. Now you can see that this number is smaller than that one. So therefore delta F will be negative regardless of its volume fraction. It's always negative. So therefore we have to draw that like this. Right? So that is B less than 0. B less than 0. So when B greater than 0, delta F is positive regardless of the volume fraction. When B is less than 0, right? So regardless of the volume fraction, this is 0.